Alrighty, howdy folks. Let's continue with chapter 4. This is the benefit cost analysis. We are continuing with comparing alternatives. Earlier, we saw the present worth method, and this second method is what is called the benefit cost analysis. All right, let's see how this works. The benefit cost analysis is often employed by government units, since the motivation for those units is not to make a profit, but to provide benefits to the public. However, providing such benefits will have costs associated. Right? Does that make sense? Government is the one that needs to build bridges, for instance, or lay roads. So when they do that, they are not necessarily looking to make profit. They just want to, but then they recognize it's going to cost some money, so they just want to make sure that it's the costs are reasonable and it is providing proper benefits, adequate benefits to the public. Would you agree that building a bridge across a river would reduce the amount of the commute time and commuting distance for some people who need to cross the bridge every year? So quite every day rather. Quite possibly up, up until then, they would have to drive far away uh, to another bridge and cross that bridge and again drive back far away, right? Instead, if there is a bridge right there, then they would save a lot of time and money. So that's a benefit to the people. So this benefit cost analysis is the one that allows you to figure out whether to pick up a project or not. Okay. All right. This is also called the cost-effective analysis. Government pursues four different classes of projects. One is cultural development, and that is enhanced through education, recreation, historic, and similar institutions or preservations. Hmm, does it make sense? Cultural development, it's called. Government is the one that needs to build schools, even though there are some private schools, public schools. Government does that. And parks and recreation, government builds parks. And also historic places. Like if you go to Springfield, Illinois, that's where they have Lincoln's, that's the Lincoln's hometown. And so somebody needs to maintain that. And so things like that. So cultural development is one project under government. Another one is protection, military services, police and fire protection, and the judicial system. Okay, self-explanatory. Economic services include transportation, power generation, and housing loan programs. Ah, wow. What is that thing called? HUD, housing and urban development. There's something like that. Okay. So they take care of, the government takes care of these kind of things also. And finally, natural resource projects entail wild land management, pollution control, and flood control. Man, New Orleans is one place where because the the city is below the sea level. Did you know that? And havoc can easily be caused in a place like that. And so they need to control the what's that, Mississippi River that flows in there. So flood control, and that's done by Army Corps of Engineers, I think, if I'm not mistaken. And all that is again a government thing. And the two most common forms of benefit cost analysis are benefit cost ratio, B over C, or benefits minus costs, where B represents benefits and C represents costs. Cool? All right, let's move on to some uh, definition. Disbenefits. Disbenefits are negative benefits such as inconvenience, home displacement, reduction in ownership, etc. What do they mean by that? Okay, let's take something like building a road, brand new road from city A to city B. So that road needs to pass through some certain places. And what if there is somebody's house on the way? So you have to get those people to move from that house. So home displacement, they need to be displaced from that place because the road is going to run right through their house, right? So that is the disbenefit to especially that the homeowner. And also, when all this road construction is going on, there would be quite a bit of inconvenience to the local public, right? And reduction in ownership. All these are disbenefits. Mathematically, the benefit cost ratio can be expressed as benefit cost ratio B over C of J sub J of I. Ooh, what in the world is that? Well, J here is nothing but the different options. J can be 1, 2, 3, 4, or so on, where each one would be an option. If there are two options that you are checking to see, then J would take on values of 1 and 2. 1 represents J equals 1 represents the first option, J equals 2 represents the second option. As simple as that. Okay. And I here is, well, this benefit cost ratio based on a particular minimum attractive rate of return or interest rate for the firm. Okay, and that would be something sigma t equals 1 to n b sub jt times 1 plus t to the negative t all over sigma t equals 0 to n c sub jt plus times 1 plus I to the negative t. What in the world is all of this? There's nothing to panic, right? It looks complicated, but it's fairly straightforward. The variable t simply represents the year. That's what it's always been representing, right? So what can happen? T equals 0, 1, 2, 3, and let's say the project runs for n years. Like you build a bridge that's going to last for 30 years, let's say. So then n would be 30 years. What is called a planning horizon. So when they have a project, they have something like a planning horizon. How long do we expect this to work? At which time, once it reaches that time period, we may need to think of modifying this project or repairing this or doing something else to this project. Okay, so that is n. So t goes from, in this case, 1 to n. Why do they say 1 to n? Whereas, if you notice, the bottom one has t equals 0 to n. What's up with that? That's something we need to think about. And also, what is b sub jt? As simple as b is the benefit for option j, 1, 2, 3, or whatever the option is, and a t. Well, at t equals 1, there may be a particular benefit. So, for instance, as a result of building this bridge, the very first year, we were able to save, the benefit to the public was $1 million. Okay, because they didn't have to drive far, so there was $1 million benefit. So that would be first year, B sub first option and first year. And now we want to, by multiplying this by 1 plus I raised to negative t, 1 plus I raised to negative 1, what did we do? Oh, we are finding the present value of this benefit. Similarly, we go to t equals 2 and see if there was any benefit for this option j and project it back to the present t equals 0. And we do that to every one of the benefits all the way from t equals 1 to n and add up all those benefits, right? Cool. And Let me answer that question that I posed. Why is it that t equals 1 to n? Because you're taking up the project at t equals 0, right? The assumption is at t equals 0, you picked it up and you figured out and you got the project done. And the benefits, you won't reap the benefits until a certain period of time, right? So 1 year or 1 month or whatever the t is. So at a later time, you will start to reap the benefits. And so that's why t starts with a 1 in this case. Now let's look at the bottom. Similar idea. At different times, you may incur different costs for each option j. And so you are trying to find the present value of each of those costs. But now, can you answer why it should be t equals 0 to n here? That's because when it comes to a cost, it is perfectly possible to see that there would be a cost at t equals 0, right? If the government decides to purchase a machine, well, that's a cost at t equals 0. As a result, the government may have a benefit, but that benefit won't show up until the first period, right? So that's the idea. And as the benefit minus cost as simply here we are dividing the sum by this one, whereas in the case of b minus c, you subtract b sub jt minus c sub jt, and of course all of them you push back to the beginning of t equals 0. All right. Here we said t equals 0 to n for b sub jt, but the truth is it's possible that there is no benefit at t equals 0. Right? This may be b sub j 0, t equals 0, maybe 0 for all the options. That's a possibility. Okay, where yeah, these are the net public benefits. Net public benefits, that is benefits minus disbenefits expressed as money associated with alternative J during year T, where T is somewhere, it takes on any value between 1 through n, 1, 2, 3, 4, all the way up to n. And these are the net government costs associated with alternative J during year T, like I was saying. And I is the appropriate interest or discount rate, and N is the length of the planning horizon. How long is this bridge going to last according to our plan? How long are we planning uh, for this bridge to run? Where we'll have to think about repairs or something else, completely dismantling it and building a new bridge. That's the planning length of the planning horizon. How many years is that? 10 cavemen with a remaining life expectancy of 10 years use a path from their cave to a spring some distance away. The path is not easily traveled due to 100 large stones that could be removed. The annual benefit to the tribe if the stones are removed is $6. Each stone can be removed at a cost of $1. The interest rate is 2%. A. Compute the benefit cost ratio for the individual who removes the 100 stones. Compute the benefit cost ratio for the individual if the task is undertaken collectively, with each individual removing 10 stones. What maximum amount may be charged by a manager who organizes the group effort if the minimum acceptable benefit cost ratio is 2? Okay, let's see how to do this one. Solution. From the individual's perspective, part A, what happened in this case? Just one individual decided, okay, he's going to take on this project of removing all the 100 stones, right? Good. What happens? Benefit is $6 during each of the years, 1 through 10. The life expectancy of 10 years, that's a indirect way of saying that the planning horizon is 10. So for each of those years, the benefit is $6, right? For the whole community. not necessarily for that individual. So when they say the benefit, annual benefit to the tribe if the stones are removed is $6, they're talking about everybody in the tribe. The annual benefit is $6. Okay. And then what? The cost. Well, 100 large stones, each stone can be removed at a cost of $1. So that individual will be expending 100 times $1, a total of $100 during year zero, right? Because the individual is taking up the project on, on his or her own. Then, what can we do? What is the present worth of these benefits? So, do you see the benefits? What are the benefits? Benefits are clearly a uniform series, $6 during 1 through 10 years. And so that's the only benefit. So we can apply our good old formula. $6 times 1 plus I is 0.02, 2% is the interest rate, and N is 10, so plug and chug, and that turns out to be $53.90. So the present worth of all those benefits for those 10 years, each year $6, turns out to be equivalent to $53.90 today. Cool. Present worth of the costs. What are the costs? $100. When was it incurred? During t equals 0. So how do we find the present cost of the $100 during year 0? Trick question. What is the present worth of the cost $100 during year 0? Well, it's already a present cost because we are talking about time t equals 0. So the cost is just 100. There's nothing multiplying by this some factor or anything like that. It's just 100, right? Okay, so are we ready to find the benefit cost ratio? Yeah, benefit divided by sum of all the benefits divided by sum of all the costs. And that turns out to be 0.5390. That is less than 1. That means the numerator benefit is less than the denominator. That's why this is a fraction between 0 and 1. And of course, these will always be positive. And so, what should we do? Any idea? Benefits are less than costs, right? Common sense tells us, nah, in that case, don't do it, man. Yeah, there are some benefits, but it costs more than it benefits. So don't do it. Since B over C is less than 1, the project should not be taken up. Which, in other words, yeah, that's a important thing to know. That means do nothing is a preferred option compared to a single individual doing all the work, moving all the 100 stones at a cost of $1 per stone. That is a bad idea. So it's better that individual does not do it, and do nothing is better than that. Cool. Now, benefit minus cost, we could have figured out 5390 minus 100, and that's a negative quantity. That's another way. Do nothing is the preferred option since B minus C is negative. Cool. We'll do a similar analysis for B and C and then figure out. Cool. Compute the benefit for the individual if the task is undertaken collectively with each individual removing 10 stones. So now for each individual, benefit is still the same $6 during years 1 through 10, and cost is $10, right? At t equals 0. Because for an individual, the individual who is actually contributing to this, from that person's point of view, if the person is thinking, should I do this or not? Okay, apparently there are 10 more people. They kind of seem to be interesting, but let me ask myself, should I do this or not? Okay, from my perspective, how does this look? That's what we are presenting here. So the benefit, that individual should look at it as the benefits are $6 and it's going to cost me $10 during year zero, right? And so present worth of the benefits is again the same concept, and that will come out to be the same as the previous number, 5390. But when it comes to the cost is only $10, right, for that individual. So the benefit cost ratio is 5.39. That is definitely greater than 1, or in other words, the numerator is bigger than the denominator. That is, benefits are far outweigh the cost, and therefore they should take up this project. Or benefit minus cost is positive 4390. Again, even that tells us that the project should be taken up. An individual moving 10 stones, that's a good idea. Finally, what maximum amount may be charged by a manager who organizes the group effort if the minimum acceptable benefit cost ratio is 2? What maximum amount will... So um, here we want the benefit to cost ratio to be 2. Benefits benefit is not going to change, right? It's done $6 every year for 10 years. So the benefit, if you find the present value of it, is going to be 5390. And so the question is, what in the world is C? What should the cost be? We want B over C to be equal to 2. So that means C must be what? Do math. Multiply both sides by C and divide by 2, right? That concept. Then B over 2 must be equal to C, or C must be B over 2. So the cost must be $26.95. If a manager charged $26.95 initial charge, then there is still a benefit cost ratio of 2. So there is still a benefit. So that's what the manager can charge. Okay, that's a good problem. Now let's look at one more. A highway is to be built connecting Mod and Bowlegs. Route A follows the old road and costs $4 million initially and $210,000 per year thereafter. Okay. You civil engineers, you need to take a good look at this one. These are the kind of things that you quite possibly will be doing. A new route, B, will cost $6 million initially and $180,000 per year thereafter. Route C is an enhanced version of Route B with wider lanes, shoulders, and so on. Route C will cost $9 million at first, plus $260,000 per year to maintain. Benefits to the users considering time, operation, and safety are $500,000 per year for A, $850,000 per year for B, and $1 million per year for C. Using a 7% interest rate, a 15-year study period, and a salvage value of 50% of first cost, determine which road should be constructed. Okay, big long problem. So if you want to pause the video, read it over to get a sense of what it is, what this is saying and what it is asking, please do that. And I'm going to move on to talking about the solution to this problem. So there are 3 routes, Route A, Route B, Route C. So let's do benefit cost analysis for this one. I think I may have done benefits minus cost for this. Let's see. For Route A, benefit A, for option A, that is what, if you look at this one, Route A follows 4 million or 2, see, benefits to the users are $500,000 per year for A. So that's exactly what we said. $500,000 per year. That's the benefit for option A. Cool. Cost C sub A for option A. What are the costs? Let's see. Route A follows the old road and costs $4 million initially right? And $210,000 per year thereafter. So $400,000, sorry, it's $4 million plus $210,000 per year. Fine. Salvage value. Whoa, whoa, whoa. Salvage value is 0.5 because it said 50% of the first cost is a salvage value. So salvage value is 0.5 times. What is the initial cost? Initial cost is 4 million. So half of that would be the salvage value. Cool. Anything else? I think that's about it. So we can do a benefits minus cost for this one. Understand time value of money. You cannot just add numbers. You have to, in order to add or subtract uh, numbers, you have to consider the time value of money. That is one of the first principles that we learned. So project every one of these things to t equals 0 and then figure out the benefit and cost. So $500,000 per year, that's a uniform series. And we are doing A, that is B sub A, benefit, times 1 plus I, the quantity raised to n minus 1, over I times 1 plus I to the n, that concept. And also, the salvage value is the future value at t equals 15, and push that back to t equals 0 by taking the $2 million and multiplying that by 1 plus I raised to negative n. So that this square bracket stuff takes care of the benefits. Minus, now let's do the costs. The cost is saying $210,000 per year. So figure out the present worth of each of those uniform series ones. And on top of it, add the initial cost of $4 million, right? Cool. And when you do that, it turns out to be negative $633,812.90. And for route B, a similar analysis. If you watch this, there's a benefit is $850,000 per year for B. So that's what we listed here. And cost is, it costs $6 million to begin with. Where the hell is that? Here. A new route B will cost $6 million initially. So that's what we are saying here. And $180,000 per year thereafter, per year. And salvage value is half of the initial cost of 6 million. So salvage value is 3 million, which is a net benefit. And so we will include that in the benefit and do a similar process as what we did for option A. And when we plug and check the numbers, we get a whopping $1,189,640.44. That's a positive number. That is definitely better than option A, which was negative. All right. Finally, for C, similar thing, $1 million and this and blah, blah. That turns out to be negative $629,136.55. Okay. So since route B is the only one with a positive value of B minus C, ta-da! Route B must be chosen. Amigos y amigas, adios.